In this video, we're going to talk about evaluating limits using a calculator. And a calculator is a great tool to use when our function doesn't have any quick algebraic manipulation we can do to see the limit, or maybe when we don't have the tools yet to analyze this function. The first function we're going to look at is the limit as x is approaching -3. And the first thing we want to do when we set up our table is we want to create values both as we're approaching -3 from the left and as we're approaching -3 from the right. So we divide our table into two sides around that critical value of -3. The next thing we're going to do is plug in the function in our calculator. We're going to go to y equals and enter this rational function. Alright, I now have this function graphed in my calculator, so now I'm going to go to the graph just to see what it looks like. It looks like as we're approaching 3 from the left and as we're approaching, -3 from the right, that the behavior of that function is similar. So now we want to find values to put in our table, and I will show you two ways to do this. The first is we can go to trace and then type in our first value, which is going to be -3.1. This gives us a value of -0.248 that we can then enter in our table. The second way we can grab values from this function is from the home screen. If we go to variables and then scroll over to our y vars and then go to function, we can grab our y1 function because that's where we plugged it in, and then we can evaluate this at the -3.01, which is the next value in our table, and get our value this way. Now, using whatever method you like best, you can go in ahead and fill in the rest of your table. It looks like as we're approaching -3 from the left and as we're approaching -3 from the right, we're approaching this value of -0.25 or -1/4. Therefore, that's going to be the limit of this function. A final way to see this on our calculator is go to window when we want to reset this. For our x, we want to make sure we have this critical value of -3. So I'm going to go from -3.5 to -2.5. That will include my critical value of -3. And then I have a pretty good idea of what my limit looks like. So I'm going to set the y minimum to -0.26 and my y maximum to -0.25. Both of these include the critical values. I'm going to graph it, and we can see that the behavior from the left matches the behavior from the right, and that we do have that hole at x is equal to -3. For this next function, I'm going to follow very similar steps. One quick trick is to make sure that when we are plugging in trig functions that we want our calculator to be in radian mode, because that will help us see the action on the graph a little bit faster. Alright, I now have this function plugged into the calculator, and I'm going to go look at the graph to have an idea of what's happening. Looks like as we're approaching 0 from the left and as we're approaching 0 from the right, we do reach a limit. I'm going to zoom in a little bit closer to see. For this zoomed in look, I'm going from -2π to +2π on my x-axis, and then just from -1 to +1 on my y-axis. And we can see that that limit as x approaches 0 appears to approach 0, and then I'm going to use my trace function to verify. There's my first value in the table, -0.049, and then I will fill in the rest. We can see with these filled in values, as we're approaching 0 from the left and as we're approaching 0 from the right, we're getting a limit of 0 for our function. Alright, in this next function, we're looking at end behavior. We're going to start in the same way. Plug this function into our y equals. Now that we have this function plugged in, I'm going to look at it on a graph. I usually start with a standard 10 by 10 graph just to get a feel of what this function looks like. And it does look like we're approaching a horizontal asymptote as we are approaching infinity. Now we just want to kind of zoom in on this asymptote and see what it really is. To do this, I'm going to use the table function, which will give me values. Right now, I have the table going up in steps of 1,000. A tip for how to do this is if you just hit plus, say I said +1, then the table is going to go up in steps of 1. If I hit plus 1,000, it's going to increment in steps of 1,000. And as we can see, as we're plugging in these large numbers, it looks like we're approaching an asymptote of 0.5. Another way to look at this is to go use our first method again. We want to grab that y variable function. And I'm just going to plug in a really big number. And as we can see, the bigger that number gets, the closer we're getting to our asymptote of 0.5. Therefore, the limit for this function is going to be positive 0.5 or positive 1/2. For this next function, we're going to start in the same way. We're going to plug it into y equals. To find the absolute value, we're going to go to our math, scroll over to number, and absolute value is the first choice. We'll drop that into our fraction, 3x over x. Again, we're going to our standard zoom to look at this. This first part of the question is asking what happens as x is approaching 0 from the right. And as we can see, we're approaching positive 3 as we approach 0 from the right. The second part of this function asks what happens as we approach 0 from the left, and as we can see, we're approaching negative 3. You could verify these numbers using a table or by zooming in on the graph. Because the limit from the left does not equal the limit from the right, we know that the limit at 0 does not exist. If we were to plug in 0 for our function, we would get 0 over 0, which is an undefined form. And because our limits also do not equal, we know that at 0, the function does not exist or is undefined. This next one, we're going to follow similar steps. We're going to plug it into our y equals, and then we're going to graph. We can clearly see from the graph as we approach 0 from the left, we're blasting off to positive infinity. As we approach 0 from the right, we're blasting off to negative infinity. And these sides do not equal. We're also blasting off to infinities, and therefore the limit will not exist. For this last one, again, we're plugging it into our y equals, and then we're going to go to the graph to see what this function looks like. We can see as we're approaching 0 from the left, our behavior is similar to that as we're approaching 0 from the right. So it looks like we do have a value, a limit right here. We're going to zoom in and see if we can get a better idea of what that value is. Here we can see a zoomed in function going from -1 to +1 on the x and -1 to +1 on the y. And in order to find out what this limit is, I'm going to set up a table of values, similar to what we did in the beginning. Alright, I have my table of values set up as I'm approaching 0 from the left and as I'm approaching 0 from the right, and they're centered on my critical value right there of x equals 0. I'm going to fill in this table using the trace function and see what my limit is. As we can see, as we're coming from the left and as we're coming from the right, we're approaching that value of positive 2/3. Therefore, the limit of this function is 2/3. So just to conclude, some tips when using your calculator is to plug everything into that y equals function, so then you don't have to retype in your function every time. To graph it, to get an idea of what your function is looking like as you approach that limit, and then to also use the trace feature to fill in your tables.